Okay. Hi, everyone. If you're yes, ready to go, indeed, Tim. We've got a bunch of people on the stream already. Thank you very much for jumping in there. I'll just give it, I don't know, maybe like another 30 seconds, let it all buffer up and be happy. Cool. I can see from my preview that we've got the slides up and you've got my head there. And we should be good to go in about a minute. Okay, everyone. I think we should kick this off. So it looks like the streaming's working, which is great. Everyone's there, no complaints on the channel. You've probably all seen the Slido link. I will flick back to that in a second. I'll just take this opportunity to say welcome. So I will just double check. Yep, participants, great. Awesome. I've just paused sharing so I can properly say hello and welcome. Thanks for joining us tonight at BrisJS's June live stream. It's awesome that we've got 3 great presenters tonight. Thank you very much for jumping in, folks. I know last week was a bit sketchy. We were left in the dark, going, oh, actually, you know, everyone's too busy and stressed out this month. We may not have one, but everyone came and everyone retweeted lots, and everyone came to our aid. So thank you very much for that. That's been fantastic. And hopefully we can keep that momentum, that energy going for the months coming ahead. We are going to be doing this still for a couple of months at least. You know, as we're all slowly but surely in different states returning to work, and in Queensland, and specifically Brisbane, we're targeting around a mid-July-ish return to work for most people. But then we'll probably wait and see and assess based on risks at that point as well. And we'll be able to announce through all the normal socials and channels where we're holding the events. And without further ado, jump back into the share. All good. So if you want to be able to, you know, raise some questions during the event, and you want to be able to say, oh, you know, what was your experience about this, or is there anything interesting you can add about that? Feel free to just drop in as many of these questions and comments for the presenters. We'll circle back around to the end of the presentation, make sure that I'll read them out, relay them to the presenters, and they can have the opportunity to be able to respond then. You can also just go and vote in some of our polls. I'll throw them up at the end of the night for sure, and that'll be able to give us some feedback and some ratings just to know if we're doing okay with this. Any ideas and comments, suggestions, very welcome. Also, there's a prize if you can answer a question correctly that about a topic from one of our presenters tonight. So I'll give you some more information about that shortly. So while we're all distributed, I think it's still really important that we acknowledge the traditional owners of wherever you are right now. You can find this out using the magic of the internet, and do pay respects to its elders, past and present. If you've obviously managed to find us, and I think that most people will have found us through Meetup or one of the socials at least. If you go and use the Meetup event, you will be able to RSVP, and it'll give you the direct link to this YouTube live stream. It also just helps me with sort of stats and tracking and understanding how many people are interested and what folks seem to respond better to, and what kind of things that we're interested in listening to. Hey, we're seeing some folks from Sweden. That's awesome. Hi. From Brisbane, Australia, and abroad. We love to have you on the channel. So thank you very much for attending the stream. We do have a code of conduct, whether or not that's been in our in-person events or online. We want to make sure it's a harassment-free experience for everyone. So please do check out our code of conduct on the brisjs.org site. You can find that there on that link. That includes online, where we've got comments here, and we try and make sure it's civil for everyone. This was super important. Please make sure that you submit a talk. Also, if you maybe don't feel comfortable sharing on a particular topic because you're curious, or you want somebody else to do that sharing, you can also request to talk. So you can put in that, I would love somebody to do a talk about a particular thing, and we'll tag it appropriately on GitHub, and it will actually go through and show up in our speaking page on brisjs.org. But yes, please do submit talks. I've been throwing out links on Twitter and BrisJS for BrisJS events quite regularly. We want to try and build up a bit of a backlog now. I understand it's pretty hard. Everyone's sort of having to deal with this changing sort of work environment. But this is a good opportunity, I think, for to capture a pool of people outside of Brisbane as well, maybe bring in some talent. But we do want to highlight Brisbane voices as well. So I want to make sure that everyone gets it and gets their fair opportunity. So if you're not sure how that works, it ends up going into our GitHub issues, and we tag it, and I add in various things there based upon the schedule for each month. So if you want to know what's coming up, you can also track it there. I will be posting out those things as soon as the lineup is final. We've got plenty of social pages, so you're obviously on the YouTube live stream if you're looking from home. There's the Facebook page and the BrisJS Twitter. They're the main ones that we've got going on. I've been trying to be diligent and putting up the events on the BrisJS Facebook as well. Yeah, brisjs.org. If you haven't checked that out, that has some of the links like we mentioned. And it also importantly has this jobs board. So people can post jobs on our GitHub as well, and those issues will turn into things on here, which is really important during this time. I know a lot of people have had to be looking for work again. Some of the organizations have been downsizing or struggling through the COVID-19 situation. So if you do have opportunities that you want to be able to share, please send them to me, or put them straight onto the job board, and I'll tag them and they'll appear on there immediately. If you're a job seeker, please check that out. Do reach out. Try and help as best I can. I get people sort of contact me all the time, and I always try and help. So with no further ado, we're going to go into some of our sponsors. Now, I've been going through and sharing the sponsor deck from pretty much our in-person events all the time. So we're going to tweak that slightly, because we've been starting to get these giveaway offers, sponsors, and things like that. So this is true to form. Anyone giving us anything to give to you, these are the people to contact. So I work at this company called PCCW Global. They are super keen to keep our community going. I've been really lucky with the support that I've had from them. So they are making this Zoom to YouTube streaming thing possible by sponsoring our Zoom Pro membership. They're also keen to keep extending that, so I'm trying to chat about any other ways we can try and offer things for the speakers in the community. So watch this space. But they're just really keen to keep the Brisbane community innovating and discussing and having these kinds of meetups. So thank you very much to them. And they're looking to hire a whole bunch of people. So in the Brisbane team, they're mostly working on a platform called Console Connect, which is a direct automation platform for internet connectivity between businesses. And so you can check out more on their site and consoleconnect.com. They're looking for release train engineers. Actually, no, that one position's filled. My apologies. I have to remove that from the slide. So there's mid to senior JS developers they're keen for, Java, Kotlin software engineers, and some systems engineers or sysops folks. They would be very welcome. So do get in touch with me and I'll be able to pass you through. There's also a link there that takes you through to the LinkedIn board. So I mentioned earlier that we've had a giveaway sponsor, and that is Wallaby. So Wallaby, you may know them from Wallaby.js and Quokka.js. They have been working out of the Gold Coast for I don't know how long actually, but they reached out over the last 2 months and sort of said, hey, you know, while everyone's doing this stuff from home, we want to keep everyone very productive and want to reach out to the development community. So they offered to be able to give away some licenses to Quokka and Wallaby. So I'm going to try and pick out a memorable question from one of our speakers' presentations tonight and pop that up in the Slido question. So watch that area for a poll that pops up, yeah, you're in the running. Anyone who can answer that question correctly will be picked out from random then from that pool. So yeah, Wallabies provide sort of these IDE enhancements to be able to get like live debugging of your code, and it runs all your tests automatically and shows the test results against them on a functional level directly in your editor as well. So Quokka has like a real-time interpreted, and Wallaby has like this test automation just showing in your editor directly in line, which is wicked. So do check them out. Now, without further preamble, we're going to crack into tonight's presentations. So we've got 3 awesome volunteers tonight. Thank you very much, folks. So we've got the introducing Frontend Application Bundles talk. Docker for Frontend. I like that. It's kind of catchy. So Erwin van der Koogh is going to tell us about all that, and then we're going to move straight into Ben's chat on saying goodbye to passwords and hello to WebAuthn, which should be awesome. And then we'll round out the night with Christian's presentation on our path to NextJS. So we've got an awesome night ahead of us. So I'm super keen. And I'm going to now just stop my share and throw to Erwin. Erwin, are you there?
I am indeed.
Welcome. Thank you very much.
Hey, sort of Brisbane and Sweden apparently, from not so sunny and very cold Melbourne. Let me get this show on the road. No, Zoom. You still have this screen sharing disabled, Kevin?
Give it a red hot go.
There we go.
Working.
There we go. All right. So yeah, as Kevin said, my name is Erwin. I'm the CEO of Link.sh, a tool, sort of CI/CD tool specifically built for sort of front-end developers. And we'll talk about that in a little bit and why that's relevant. So yeah, like the first question that sort of pops to mind when we're talking about front-end application bundles is like, what are they? And so to answer that question, like the first question I want to answer is sort of what's a front-end application, just to sort of make sure that we're talking about the same thing. And what we mean by a front-end application is an application that runs in a browser and talks to sort of one or more APIs, sort of backends over APIs. So we are not talking sites. We're not talking like sort of. We're talking maybe e-commerce sites. They could be SaaS, sort of SaaS applications, sort of dashboards. It's more than just a website. There's a lot of sort of dynamic things going on. Because then we can talk about sort of what's an application bundle, a front-end application bundle. And basically what a front-end application bundle is, and this is a sort of a long sentence, so I'm going to take a sort of deep breath and go, it's an immutable deployment artifact specifically designed for front-end applications that allows any such front-end application to be hosted on any platform that supports JavaScript. And because sort of a picture tells you way more than this is sort of what we're trying to accomplish. The JavaScript community is obviously famous for coming up with many different solutions to the same problem. So we have a lot of different frameworks, right? There's React, there's Vue, there is Ember, there's Angular, there's Svelte, and they all do things in sort of like very different sort of ways. But even if you look inside those communities, there's again sort of a lot of different frameworks. Like there's Bootstrap things like React app. There's sort of NextJS, fully server-side rendered, Gatsby statically rendered. So there's a lot of different variation on the left. And what we're trying to be is the sort of lingua franca between sort of all of those and hosting providers. Things like AWS Lambda, Cloudflare workers, Heroku, sort of Vercel, which is sort of the new name for Zeit, sort of Docker containers. And fabs is the middle. Like, so everything can go to a fab, and a fab can be deployed everywhere else. Right. So the next question becomes sort of like, if that's what a fab is, why would I want one? Right? Why would I want a fab? And there's two reasons. The first reason is to throw off the shackles of static hosting. And the other one is to democratize amazing CI/CD. So what do we mean by throwing off the shackles of sort of static hosting? Now, traditionally, there's been sort of two major ways of hosting your front-end application, right? Either you hosted them on a sort of static sort of hosting, and this can be like an S3 bucket, Surge, Netlify, sort of like many static hosting providers sort of out there. And sort of what they are is they are reliable. They're very scalable. They're very cheap, and their functionality is limited, of course. And on the other hand, there is like running your own servers to host your application, which is extremely powerful. It's extremely flexible, but it's incredibly hard to keep them running. It's even harder to scale them during traffic bursts or anything else. And it is really expensive, especially if you factor in the cost of sort of paying the people you pay to keep running them. And so, yeah, like what happens is static, extremely convenient. I don't need to monitor this, right? If my static hosts go down, like there's not even a point to page me, because like, what am I going to do? Like reboot S3? So what has happened though is that static hosting is so good that it has changed the way that we write, build, and deploy software, often for the worse, right? So some of the limitations of static hosting, like the biggest one is that there's no routing, right? So like very often we have like a catch-all thing where if you can find any file here, just serve out this HTML file. But it means that we can't serve out different HTML easily for different dynamic routes. There's no real way to control headers. Like cache control is hard, redirects, things like content security policies are all really hard to do well. There's no way we can do dynamic preloading of sort of assets. And my main one is environment configuration needs to be built into the HTML, right? Now, as a traditional sort of backend developer, when I came to frontend, this was one of my biggest things that I saw, right? So this whole, we create a build per environment. So what we do because of this, and this is sort of like the way we deploy applications, is we test locally. We create a build that we do local and we test it locally, and then we deploy to the sort of dev server. So we build a dev server specific sort of bundle, and we upload that, and then we test it and go, this is great. And then we take the code and we throw it away. And then we build a new test environment bundle, and we deploy it on the test environment. And we test it, and we go, this is great, this is great. And then we take the code and we throw it away. And we go and grab the staging one, and we test, and we throw it away. And then we build sort of a production deployment that we then deploy, right? So all leads to sort of problems, and they are there because static hosting is just so good. But Erwin, and then sort of insert your hosting provider here, sort of allows me to do most of that. And I go like, yeah, they sort of do, maybe. Maybe there's like a vendor specific, very untestable sort of configuration file. The sort of most advanced one of this is Netlify, right? The Netlify toml that you put into your sort of distribution is pretty darn configurable. Like you can sort of configure redirects there and sort of like include what headers to do. But yeah, it's config. It's hard to test. So yeah, and it's limited, right? You can only configure the things that they have configurations for. So what are some of the things that we could do? Like if we could run JavaScript at the edge, right? So instead of serving a HTML file, what instead like a JavaScript function was called? And there's some really cool stuff we can do, right? We can eradicate waterfalls with dynamic preloading, right? Right now, like what often happens is we serve an HTML file to the client, and we've done some sort of chunking. So the first JavaScript file that we sort of load figures out that it needs another JavaScript file, and it then goes and sort of requests the file, and it goes back and loads the second file, and maybe the second file decides to need a third file. And so you get this sort of like waterfall where we discover very late that these files are required. And if we could run JavaScript, we could sort of go like, well, if it's this route, you're going to need these two chunks of JavaScript, this CSS file, and these three images, right? Speeding up. Other things we could be doing is like radically improving the security of our applications by limiting all interactions with one origin. Like, so we can sort of go to our server and proxy our API requests, and even proxy our sort of third-party scripts. And what allows us to do is set a sort of like same site cookie, like that's only used for over HTTP. And like that radically reduces things like cross-site scripting, so the blast radiuses. Right. Another thing we can do is do the initial API requests on the server and send the result of that API request in the script tag to the HTML to the browser. Right. So the initial API request is done by the server, which almost certainly has a better network connection, but also has a TCP connection open, shaving potentially hundreds of milliseconds of an API request. Right. And sort of one of the sort of more important things, it can inject that environment config into the HTML dynamically, rather than having it having to be built in sort of at compile time. So these are just some of the things we could be doing if we could run JavaScript at the edge. And the good news, obviously, is that we can actually run JavaScript at the edge now. There's AWS Lambda at Edge. There's the Cloudflare workers. Netlify is about to release sort of a similar thing where you can run sort of JavaScript in any of their data centers. And this is on top of sort of like a whole bunch of JavaScript PaaS services, like sort of Heroku, Vercel, and some of the other ones. Right? So we have this capability now, and that's what's sort of such a game changer, right? Because this gives us the best of both worlds of sort of static hosting and server-side hosting, right? The edge, JavaScript at the edge, sort of a programmable edge, is powerful, it's flexible, it's reliable, it's scalable, and it's mostly extremely cheap compared to any of the other offerings. So yeah, and that's sort of what fabs are designed to do, right? To take your application and make it really easy to deploy to the edge. Because what we can then do is democratize amazing CI/CD. Right. And here it sort of comes in the analogy with sort of Docker, because Docker changed everything for backends. I look at this screen sort of a few times a week when I deploy our new sort of rendering infrastructure, and it still makes me giggle. Sort of 2 years, 3 years sort of later, because what sort of ECS, which is sort of the hosted Docker service from Amazon, does is it does automatic blue-green deployments, and what that means is whenever I push a new version, it will spin up the new version, but it will keep the old one running, and it will run the sort of test. It will test the service. It will check the sort of health checks, and then I can slowly move traffic from the to the new version. And as soon as something goes wrong, I can go, yeah, let's forget about this new version. Let's just go back to the old one. Right? I had to write nothing. I didn't have to configure anything. I didn't have to change my code. I didn't have to write any server-side script. I spent months of my career building custom solutions for this in the sort of mid-2000s, right? So what Docker's changed is this thing that 10 years ago we would have to write custom software for, and it would take us months. We now get for free. And that's what we're trying to do with Frontend Application Bundles, is how do we get to that point where we have this standardization that allows others to build on top, right? So why can we not use Docker for frontends? And there are sort of three main reasons. The first one is that Docker is really good if you're trying to automate one thing, like one service bundled up into one Docker container. But front-end applications have two concerns, and so they do two things. They have the server component, which does a lot of the logic, but also it does a lot of the caching and the static hosting, which we often just want to offload to a CDN. Like there's already a lot of infrastructure that's sort of tailor-made for sort of hosting static content. The other one is that Docker containers very quickly get way too large and way too unwieldy. Like the great thing about Docker containers is eventually you will end up with an entire Linux distribution in there, no matter how small you start out at the beginning. But also its flexibility is way overkill because we don't need all that flexibility, right? So what we've done with Frontend Application Bundles is we've we went an abstraction level higher, and like by not supporting everything, but focusing just on frontends, by focusing just on JavaScript, sort of what can we do? Right. And sort of this is sort of where we get to the like, how does it work? And at its basis, like a fab is just a zip file. It's a zip file with one JavaScript file in it, which is called server.js. And in this file resides all your server-side logic. And we'll talk about sort of exactly sort of how that works a little bit later. And there's a second directory, which is /_assets. And this contains all of our sort of client-side assets. So this can be sort of HTML or JavaScript or images, sort of everything else. Right. And what we can do with this one zip file, this now becomes a portable piece that we can deploy to anything that supports fabs. So the server-side component can run in any environment that can run JavaScript and Fetch. Right? So it's not built on top of NodeJS. It's built on top of JavaScript, which means you don't have any of the sort of native libraries that Node.js gives you, but it also means it's much more lightweight, which means it's perfect to run in something like V8 isolates on something like in like a Cloudflare workers, which means it can be much more secure than running like a full Node.js process. Like obviously you can run it inside a node, but if fabs are targeted at JavaScript and Fetch. And the other thing we've done is we've defined like the runtime of that host. So what we have is well-defined interfaces that both the runtime environment can program against and the fab can program against. And at its core, it's the most important sort of method is a render method. And we just go render, and you're given a request, which is just a regular fetch request. We pass in the settings, and this is sort of what's interesting and why it's so good for frontends. Because by passing in the settings at request time, we can have in an immutable deployment artifact. So you can take this fab and run it against your dev backend, or you can take it and run it against your staging or your pre-prod or your production environment, or you can run it with feature flags enabled or feature flags disabled. Right? And that what makes it so powerful. And then the last is a context, which is used to pass in information from the environment that you're running in. So this is sort of like the server-side component. And this means you have full flexibility on the server side to do whatever you want. You can serve HTML, you can send redirects, you can do sort of anything you want, as long as you return a fetch response. Right. And the second half are static assets. And the one thing to sort of know about static assets is all of these files are served with cache control headers set to cache for a year and are immutable, which basically means you need to fingerprint your assets, right? Make sure that if the contents of the file change, that the sort of URL of the file changes. And that's sort of like where we're at, right? So it's a very simple format. It's really small. Like most are the size of sort of most of the fabs are like a few megabytes at most. Instead of static assets, sort of server side sort of components. So yeah, we're to sort of learn more. Fab.dev is where we've sort of have all the documentation. We've recently sort of released sort of our first sort of release candidates for the new sort of an improved sort of fabs. They are used to run production sites for sort of multiple companies, so it's stable. We're just sort of working on adding some of the last features that we want to target for sort of 1.0. So it's sort of, and one of the we're also sort of working on some of the docs over there. There's a GitHub fabspec/fab. There's a Discord link there where either me or Glen Maddern, that some of you may know as sort of ex-Brisbane JavaScripter, currently in the UK via Melbourne. Yeah, he worked on things like CSS modules and styled component. And it's basically sort of his full-time job now is sort of making fabs work, making them happen. I just wanted to do one more thing and just show you how powerful fabs can be by doing this, right? So demo.fab.dev is a fully server-side rendered React app running on Cloudflare workers. So this is a, and here you can see that I do live in Melbourne, Victoria. If my sort of code wasn't a giveaway already. But yeah, this is a fully server-side rendered Next.js app running in Cloudflare workers, 200 locations set up around the world. That you can do sort of anything with. Where's my thing? Yeah, check out the project. Hit us up if you have any sort of questions. Love to sort of help you get started on fabs. And if you do that, do check out link.sh, which is sort of the company that we run. We give you free CI/CD to any sort of edge provider sort of your choice.
Fantastic. Thank you so much.
Awesome. Cheers. Thanks for having me.
Oh, it's a pleasure. We've got one question on here. What are some of the edge environments that we can use it on today?
That's a great question. I forgot to mention it. So like the two most important ones are Lambda Edge and Cloudflare workers.
Cool.
Cool. And sort of like a Node.js sort of runtime if you want to run it sort of yourself. But yeah, adding runtime environments is sort of easy to do now. So if you want to deploy to somewhere that isn't AWS Lambda or Cloudflare workers, put up an issue in the GitHub, and we'll just build an adapter. It's super easy to do.
Cool. Yeah. Awesome. All right. Thanks very much. Yeah, we're getting some very positive comments on the feed there. So thank you very much. Good talk.
Awesome.
All right. Cool. Yeah. Well, if anyone has any more further questions after that, and do feel free to keep using the Slido. We can always circle back between any of the different presentations.
Yeah, I'll jump onto the Slidos in the feed right now to answer any questions people might have. So
yeah, that's cool. Yeah. So yeah, thanks very much. And yeah, I guess without further delay, we can hop straight into Ben's talk. Ben, are you ready?
I think so. So I'm going to try something interesting tonight. what can go wrong, right? So I've got a couple of laptops at home, one that I use for streaming, which is MacBook Pro, but I've got a Linux machine. I'm a Linux person, and that's what I do all my work on. I want to talk to you about WebAuthn tonight. And one of the really cool things about it is that the fingerprint reader on the MacBook Pro is WebAuthn enabled. So I want to switch between multiple things. So what I'm actually going to do is, rather than sharing my screen, I'm going to share the output of OBS, which is what I use for streaming. So theoretically now, Kevin, maybe you can tell me if this is working. You should be able to see my designed frame thing. Actually, I can look at the YouTube video here, can't I, and see what's going on. Of course, there's a delay on that. So, but you can hear me? Okay. And you can see the text saying, say goodbye to passwords and hello to WebAuthn.
We sure can. Sorry, I
Sweet.
didn't realize I was on mute.
That's right. I saw you nodding. And I was thinking, have my headphones broken again? Because when I joined the Zoom chat first tonight, headphones weren't working. Technology, eh? It's a fantastic thing. So thanks for having me. Thanks, Kevin, for inviting me to come back to BrisJS. Unfortunately, this time, not in person. I'm very sad about that. But I want to talk to you today about WebAuthn. So this is where I can only say hands up if you've heard of WebAuthn. It's a fairly new technology. I won't actually get people to say anything in the comments or anything. I'll kind of keep an eye on it. But yeah, just going to start my timer here because I'm really bad at making sure I go to time. WebAuthn is basically a replacement sort of for passwords. But before we go into that, I'll take you through like where we came from, how WebAuthn works, what it's good for, and what the next steps are if you want to try it out. So before I do that, I'll just get my clicker working. There we go. My name is Ben. I think my slides might be like 5 seconds behind my audio, but I'm sure we'll be able to deal with it. I have a security consultancy background. I was doing that for about 10 years before I joined Auth0 as a developer advocate. And one of the core things that I've always focused on is privacy, security, even the civil liberties side of things. The last few weeks have been extremely hard on a lot of us around the world. And my thoughts go out to anybody who might be impacted at the moment. The important thing for me is making sure that technology is there to protect the users. And I feel that WebAuthn is a really good step towards protecting your users even more. So what is it all about? Essentially, it's about verifying identity. And there are a number of different ways that we do identity verification nowadays. The most popular one, the most common one that you'll probably all be familiar with, is using passwords. Passwords go back to, I think, the Roman century. I think even like the knock on the door, secret knocks, are essentially a form of password. They're hard to remember. If you've got one secret knock, that's fine. But if you've got to remember a different secret knock for every different door that you've got to knock on, it's going to be hard to remember what that secret knock is or the password for getting into your online systems. The problem with them, as well as being hard to remember, is that they're easy to guess. And when I say guess, I don't mean like brute force. I mean, brute force is one way of guessing passwords, but I don't mean just hammering away. But people reuse passwords a lot. So it's easy to guess a password because it's already been used before. People use personally identifiable information in passwords, which is obviously, most of you will probably agree, is a bad thing. Most of us don't do that, but it's something that still happens, and therefore it reduces that set of potential passwords that can be used to try and break into somebody's account. Passwords are also, when I say easy, it's not easy to intercept, but compared to a lot of other identity verification mechanisms, it is fairly easy to intercept. If you've got a database breach with plain text passwords, that's a really easy way of finding people's passwords. Shoulder surfing is an easy way to find people's passwords. Passwords rely on users to create the complexity, humans to create entropy in the things they remember, and that's just never going to be a good balance. It's never going to work out in the long run. They're really hard to secure. If you use a password manager, that's one way. Some people write them down on like a big sheet of paper, which is contrary to some people's statements is probably not actually the worst way of doing it. It's better than having a shared password for multiple different systems. But Have I Been Pwned is a really good example of the number of breaches that we get and the number of times passwords are compromised and how easy it is for passwords to just go wrong. So, and this isn't something new. We've known this for a while. We keep trying to make it easier to store passwords securely. Using HTTPS everywhere is a really good way of making sure that end-to-end communications are as secure as they can be. But we're now looking at, or have been for a while, and looking at other ways of verifying identity. Another form of identity is an access card. You've probably all used one back in the days when we used to leave our homes, swipe card to get in and out of your office. They're easy to remember. It's hard to, like, you know, the swipe cards for your office. You don't have to remember which swipe card's which unless you, I don't know, you're a superintendent, you've got keys for like 400 doors or something. They're relatively hard to clone, whereas a password, once you've seen it, you can write it down, you can email it to somebody. It's really easy to clone a password. Cloning an access card requires, in all cases at least, the ability to write or emulate that card through some kind of device. But cards also have varying levels of security on them. A magstrip card, interestingly, I think it was DEF CON 2016, somebody demonstrated a proof of concept for being able to read a mag card. So there's the black strip on the back of a card, right? Technically, you've got to swipe it through something. It's got the contact, and it reads the magnetic signature on that black strip. Somebody wrote a remote reader and even a remote emulator for a mag strip. And you just hold this little device up to like the swipe card area of a credit card, and they were able to replicate their own credit cards. So those are relatively easy. NFC cards are a bit harder. You can lock those down for rewriting. The NFC and Bluetooth will provide ways of signing data or signing challenges, and the card will have something on it that will basically produce a potentially a different result every single time. The door reader will send out a unique code that the card will then sign. So you know it's that card, and it's really hard to forge that kind of thing. So we're getting a lot better on security at that point. I say here it's harder to intercept. Like, it's easy to swipe a card off a table for sure, but it's something that somebody's going to notice. If you steal my password, I might never notice because I've still got my password. It's not tangible. Whereas a card is tangible. Once it's gone, it's gone. You can be notified, you can cancel it, those kind of things.
Just want to jump in there for a second, Ben.
Sure.
I'm not sure if your slides are advancing on your streaming platform. We still see the title, just in case.
Yeah, it's a good point. Let me close that. And let's start this again. Like I said, what can go wrong?
Streams in streams.
That's it.
You looked like you were clicking in advancing slides, so I said, maybe I should try and stop him there.
No, that's still showing the same thing.
Sure is.
I'll try one more thing. If that doesn't work, then I'm just going to do a standard Zoom share, and it just means I'll have to stop sharing and resharing a different screen when I get to doing the demo part.
Hey, I see fingerprints.
Yay. All right, so let's just go back quickly. I'll show you all the screens very, very quickly. So you've seen that one for a long time. I think you all know this one really well. So that's a really nice picture of me. You would have seen that. Not so impressive. And I've mentioned all of that already. We're going into verifying identity and passwords. So this is the one that we kind of came back to. That I think I think I got to the end of this one, didn't I? No, access cards I did. Fingerprints we got onto. So fingerprints, they're really easy to remember. I shouldn't show you too closely. That's my fingerprint. Don't take a photo of that. There's actually, and I'm digressing slightly here already, there's, I don't know, some kind of security art type thing. A photographer was able to take a photo of I think it was an actual finger as opposed to a fingerprint on like a glass. And they took that photo in high enough resolution to be able to 3D print with a rubbery resin of sorts, a fingerprint that then managed to unlock a door that finger should have been able to unlock. So it's not even contact anymore. You can get them from photos. Obviously, it's quite hard. You've got to target the person you want to get to. But generally, they're easy to remember. They're hard to clone unless you have projects and thousands of dollars and whatever, and a museum willing to host your output. They're hard to change, though. That's the big thing. Passwords are easy to change, and we like that. Fingerprints are really hard to change. If somebody compromises your fingerprint, there was a scare or like a fear around fingerprint-based car unlocking mechanisms. If somebody wanted to carjack your car, they'd probably steal your finger because that's the only way they could unlock it. They are harder to intercept, and they are, on the other side, I was saying how easy or harder to secure. It's not really a question anymore of how easy or hard. It's just imperative. You have to secure fingerprints ultimately because you can't change them. So the risk of storing it, the repercussions of a leak is really high on the owner of that fingerprint. And you probably noticed from those three that there are, the three examples I've just given, there are three kind of groupings of verification mechanisms. And the question a lot of us ask ourselves maybe is, which one do you choose? Well, if you've heard of multi-factor authentication or two-factor authentication, you choose one from each group. Passwords are something you know. The cards are something you have physically in your possession, and a fingerprint is something you are. And ideally, you'll select at least two, potentially three, one from each of those groups. There's no point in having two passwords. It's technically no more or less secure. Sure, you've got to guess two passwords. But if you want to increase the complexity, you want multiple factors of authentication or verification processes. So I think we've all agreed. I've had no feedback, but I'm sure I can read all of your minds. I think we agree that passwords are a really hard way of managing this. So there's this terminology that's come along, passwordless, which is essentially any kind of verification mechanism that is not a password. So it can still be something you know, it could be a PIN code, but it's not a password. Now, there's a bit of a blurry line there, like, should it still be something you know? Because something you know, something could be stolen. But potentially passwords are the realm of just a string, whereas something you know could be something more complex. So I won't say that categorically anything that goes into the something you know category is outside of passwordless, but predominantly a lot of them will be moving on. So essentially passwordless is using any of the other two formats, something you have or something you are. Any of those will be a passwordless authentication mechanism. One of them might be like a one-time password. You might get it via SMS. So that's something you have. You have a phone, or rather you have a SIM card in a phone that receives an SMS that is a code, and that's what you type in. So we know the person who's physically got that phone has the code. It could be a one-time login link, which might go via SMS as well, or maybe via email. It could be like one of these hardware authenticators, press a button, get a 6-character code, or maybe it's on your mobile phone app. Again, that's something you have. The downside to all of these, well, these three and most of the others as well, is they're all vulnerable to intercept and phishing. What do I mean by those two in particular? So intercept is like the man-in-the-middle attempt, where we try and get the information in, actually they're both quite similar, aren't they? We get the information from the user and then use it in a way that was not intended to be. You're probably all familiar with the term phishing. Phishing sites look like other sites and get you to give information and to trust a untrustworthy site under the guise of being what you're trying to do. And the request from that middle system to the server, then to the server just looks like a request from any other web browser. So it's really hard for the server to determine whether or not the browser or the client, the entity that the request is coming from is actually the browser that the user is looking at. So FIDO 2, FIDO is the Federated Identity, I've forgotten what the O stands for. But anyway, they're like the main standards organization around identity. They have a number of different standards and protocols, and one of the more recent ones is FIDO 2. FIDO 2 is a standard. It's a standard that's designed to help web applications use hardware authenticators for authorization. And WebAuthn, the subject of the talk, is the API component. And you can see here, we've got the web browser, represented by this square, running a web application. And we have this API built in the same way as you have a browser API for, my mind's gone blank. But the browser provides a whole lot of functionality that can be accessed via JavaScript that you don't have to write yourself. And WebAuthn is yet another one of those components that comes standard in all of the latest browsers, most of the popularly used browsers, that basically provides the ability for the browser to talk to the hardware authenticator. And it does that over what's called CTAP, which is the client to authenticator protocol. So all of the latest browsers are now implementing CTAP so that they can talk to the fingerprint reader on the back of your mobile phone, or the sensor on your laptops or external cards. I've got this very tiny, I think that's one of the smallest ones. This is a YubiKey USB-C device, and it allows the browser to talk to those. And WebAuthn is what allows your web applications to talk CTAP, essentially, to those devices. So the benefit here is that, and we'll go through a bit of a workflow of how this looks. The benefit here is that because the browser has the code built into it for talking to the hardware authenticator, we've got a lot more assurance around which browser it is that's making those requests to the authenticator. It's mostly interactionless from the user. You might need to touch something to verify you're present, but the actual computation of the code that verifies who you are is done by the hardware authenticator. And therefore, the server knows when it gets the response back that it's been generated by the browser that the user who has the hardware authenticator is actually using. So the man in the middle tag is basically, I'm going to hesitate to say the word eliminated. I'm not going to say that it's totally impossible, just because there's always an edge case somewhere or a corner case that we'll find out at some point, maybe. There are obviously, and this is beyond the scope of just WebAuthn, it applies to all credentials and identity. There's always going to be cross-site injection attacks and a few other things that can make you more vulnerable. But by and large, this basically removes that vulnerability to phishing and interception that I was talking about before. So there's a website. This is the website I want to show you on the Mac. So this is webauthn.me. It's written by one of my colleagues at Auth0, but it's not Auth0 specific at all. So you can go and you can play with this. And if you've got any hardware authenticators that plug into your laptop, or you've got one of the MacBook Pros with a fingerprint sensor, I'm not sure if the Windows and Linux machines that have fingerprint sensors on them, if they work, give it a try. I'd be interested to find out from you if that is something that does work. But if I switch to this one here, you should now be able to see my Mac. So we've got WebAuthn running. I've also got Kevin popping in over here. Let me see if I can get rid of that. Now he's just going to float over the top there.
If you hit the little minus on the bottom, it'll at least get smaller. Top left.
Oh yeah, there we go. Right. Apparently I'm talking. Who knew? Right. Let's go to the top. So this is totally, and as with a couple of the other tools that we write for people to tinker around with security type things, this is all running within the browser. We don't collect any information about this. So I can actually type whatever I want in here for the username. I'm just going to put in Ben because that's my name. And I'm going to click on register. So what's happening here is you can see the browser sent a message to the relying party. So this is the server. Let's just cancel that for a second. Something went wrong. I'll have to reload this web page. Go away. So this is the server over here. Imagine this is your API, and you're trying to make a request from your browser to your API, and your API wants to know who you are. So the request comes across, and the relying party, your API or your server, is going to send back a challenge saying, here's a challenge, and I need you to sign it using a hardware authenticator using WebAuthn. So the browser will then send that off to the authenticator, which is what was just about to happen. Let's do that again. The challenge is returned, and it goes back to the authenticator. Now you can see here, this is jumped up. So this is created because I'm running it in Chrome, and Chrome is one of the ones that has WebAuthn working support. So I've got the option to use a USB security key, so I could plug this thing in, and I could use that. But what I'm going to do instead is I'm going to use a fingerprint reader. So the beauties of demonstrations and talking. Let's try that for a third time. And this time I'll actually action it. So you'll see also there was a timeout. So if it doesn't happen within a certain amount of time, we have here a 15-second countdown. I'm going to use the built-in sensor, and I'm going to go over and just touch the sensor. And you can see it sent there a signature, a public key, and an ID. So the signature public key here is basically the public key from the hardware authenticator. It generated, at that point that I touched the fingerprint, it generated a public-private key combination, stored it within the hardware authenticator, in this case within a secure area within the MacBook Pro. It's not accessible to OS X. It's in the hardware authenticator that's inside the Mac. It also has a raw ID. That raw ID is essentially the identifier for your key pair, but it doesn't relate to you. It has no personally identifiable information in it. And then obviously it also had the signed challenge. That went across to the server. The server was then able to use the public key to verify that the information hadn't been altered, and so that the challenge was basically as sent. So therefore, we know that the hardware authenticator received the challenge that the server sent in the first place, and also the raw ID. So this is essentially like the create account process that you would have if you say, give me a username and enter your password twice. We've now created an account for this person, but there's no password. So the thing that came back was the raw ID. We're now going to take this raw ID for the authentication process. So this is me coming back and wanting to log in. We want to make sure that I still have the same hardware authenticator. If I have the same hardware authenticator, then I'm who I say I am. So we can click login after having provided this raw ID here that got returned the first time. And it's going to go across and make a request and ask for me to touch the fingerprint scanner again. Notice this time it didn't give me the option of whether I wanted to use the USB device or the fingerprint scanner, because it knows for that raw ID that that was the device. That was the fingerprint scanner that I used. So we need to use the same one. It's done that round robin. The challenge came back as expected, and therefore we're now successfully logged in. So there's a lot more to this that you can do. There's some really interesting things like, if I come down a bit further, require resident key is a really exciting one. So you just notice when I logged in, it just basically asked me for me to touch my fingerprint. Now, if I did it again, it would just say, touch your fingerprint, and I'd still have to type in the username. Now imagine if the first time you log in, you provide a username, but then the hardware authenticator remembers that, remembers your username, and then next time you click on login, it gives you a list of all the people or all the IDs, the names of the accounts that people have logged in with, so the usernames. So you could have a number of different entries in that system. I wonder whether it'll actually work if I do a demo. So I do register now, and I do built-in sensor. So the output is coming in here, getting the response back. And now, yeah, I'm not sure it's actually going to work this time around. What would technically happen is if I register again, it should give me a list of identities that are stored in the hardware authenticator. I'm not sure why this is working, mostly because I've just been hacking around with this myself recently. So, but it does allow you to store, especially in one of these, which is even more useful because this is something you can carry around with you. It allows you to store multiple identities. So you can log into one site with multiple identities and have them all stored in the key. So you don't have to remember what the usernames are. You can just give them aliases and get a list of those when you log in again the next time. All right. So in summary, we all know passwords are one of the worst identifying factors at the moment in the world. They are hard to manage. There's so many to remember. Most people still don't use password managers. I would like to think that within the audience here, 20 to 30% of you at least use password managers. I would like to hope that all of you do, but it's just not something that even the whole tech community does. If you look wider afield than that, the general human population of computer users, I would say 99% of them don't use password managers. Not seriously. I mean, some people might use the built-in, I'll remember your password built into the mobile phone or the browser that they're using, but it doesn't really manage their passwords across sessions. It doesn't allow them to confidently wipe all cookies and saved logins, and they still have a different mechanism for remembering the password in the first instance. We have a really bad way of managing passwords, and that's not the fault of the people. That's not the fault of people who are choosing not to install password or use password managers. It's because human brains aren't designed to remember unique passwords for every single site. And they're not designed to use passwords in the first place. It's an edge case. To make security easier on our users, we need to make it more transparent. We need to get it out of the way so they don't even have to think of it. So at the very least, I encourage you to think about going to passwordless. It's potentially more secure, but remember that it does still suffer from the interception phishing vulnerabilities that we talked about. WebAuthn is designed to address all, if not most of those issues. So get rid of the interception phishing issues that I mentioned. Get rid of passwords. So it's basically a passwordless mechanism with much better security and makes it much harder for man-in-the-middle attacks. Remember that it's just an API to use the identity factors more securely. So it allows your web application to talk to hardware authenticators, whatever they might look like. It's not going to replace OAuth or OIDC, OpenID Connect. It's basically replacing passwords, and you'll still use your OAuth authorization flows and OpenID Connect for identification and all of those things. And it's not going to replace your identity provider. If you're already using Auth0 or using an off-the-shelf OpenID provider, they will still be needed within the ecosystem of your application. It's just giving you a better, more secure mechanism for authenticating your users. So after that little bit of a dump of data, if you want to find out more about this, the WebAuthn.me website is where you can go and play around and create your own key pairs on any hardware authenticator you've got. I've got the Pixel 2 here, so that'll work on here as well. I was trying to get it working earlier today and it wouldn't work. It gave me that pop-up dialog saying, oh, there was an error. And then I realized I didn't have a fingerprint set up in this phone yet. So make sure you've got a fingerprint set up first on your Pixel 2 if that's what you want to try. And yeah, where you can grab these little UV keys. They're pretty funky. The downside to this one here, just as an aside, is it's so small. I actually lost it. It took me 3.5 hours the other day and lots of emptying of boxes in my office to find it again. So that was fun. The Auth0 blog has a whole lot of information on identity, naturally, and there's quite a bit of information there about WebAuthn. If you want to find out more about using the WebAuthn debugger that I just went through with all the checkboxes and what they do, have a look at that fourth link there. This is the one you want to be screenshotting right now, if that's something you want to look at. And make sure my head's out of the way. Yeah, I'm not blocking the last URL. Looking at the resident credentials, that's the thing that I was going through, mentioning that it'll remember the identities of who's logged in, and it'll remember those on the authenticator. So to find out more about what that does and how that helps you and your users, have a look at that fourth link. So that's pretty much it as a wrap up. Thank you very much. I'm not sure there's any questions. I'll just jump over to.
Yeah, there is. Thanks,
Yeah.
Ben. Yeah, we've actually a flurry right at the last minute. So,
awesome.
I'll go top to bottom. I'll read out just a comment that was in the stream there. So it's not just something you have; it also needs to be something you have and find. So yeah, if you won't be able to log in if you manage to lose that key.
From Rin there. Yep, absolutely. That's one of the downsides. That's a really good point, actually. Something I forgot to mention is if you are using WebAuthn, then, or your users are using WebAuthn, there needs to be some kind of recovery mechanism. With passwords, you can get a password reset. You can't do that with a hardware authenticator because this has got all the secret keys on it. There's no way of replicating that. It's not backed up anywhere. So what you can do is there's no limit to how many hardware authenticators you can use on one account. So when you're developing your application and you're enabling your application for WebAuthn, and most identity providers will probably offer this as part of the solution anyway, the best thing is to have people use at least 2 hardware authenticators. So they lose one, they've got the other, or provide some other kind of mechanism. Maybe right. a really common one is to provide a list of like backup codes. So provide that as well, so that if somebody loses a hardware authenticator, they can still log in once and add a new hardware authenticator, invalidate the old one, and get back in.
Cool. Yeah. That's a very similar process than when you're using like something like Google Authentication or Authy. They generate you a key, and you'll have that rotating key. This is just taking that out of the equation and replacing it with a piece of hardware.
Well, essentially, the Google Authenticator is a hardware authenticator on the phone. It's using the encryption. Actually, there's probably a software equivalent. Like there might be software authenticators instead of hardware authenticators. What WebAuthn does is it gives you direct access to a local hardware authenticator, whether that's via USB, Bluetooth Light, not Bluetooth Light, Bluetooth Low Emission, so BLE, NFC, or local. So the fingerprint reader on the Mac would be a local one. It's basically providing direct link to that. So as with the Google Authenticator, you have to type in the 6 digits. This is like, no, I don't have to do anything. All I do is I press, and all the fingerprint thing is doing is actually verifying that it's me that's here. This one here has a very small, I don't know whether you can make it out if I hold it up. You might be able to see a little bit of a bronzy, silvery dot on the side of that black bit. That's actually a small piece of metal, and it detects a capacitive touch. So it just says, touch your device to make sure that you're actually present.
Cool. First question is, can this tie in on top of existing social logins like implemented with OAuth 2? I guess it'd be a separate one, wouldn't it?
Well, it would be in addition to. So you could, yes and no. You could have social login and then also say, okay, well, you've just logged back in with your Facebook account. Now what we need to do, and it could be every time, or it could be if you're trying to escalate privileges, we now need to do a hardware authenticator or a WebAuthn login. You can do both, and that's where the multi-factor comes in. So it is essentially just another factor of authentication, or another mechanism of authentication. You can absolutely link it in and layer it on top of other ones for more security. Yeah.
Cool. Is it possible for your WebAuthn identity to be shared across multiple devices, possibly using different sensors?
So the identity is stored on the device because that's where the secret key is. There's currently no way of sharing those between devices. I personally think that to do that would potentially cause quite a security risk, because essentially what you're doing is you're creating a way to extract security or the secret keys from these devices, which is going to weaken that security. So you can't share identities, but like I said before, you can have multiple keys associated with one online account. So say you're building abconlinehardware.com and you want to be able to log in, and I've got my account there. I can have 2 hardware authenticators associated with it, so that when I log in on my Mac, I can use the fingerprint there. When I log in on my phone, I can use the fingerprint on the back. But it's essentially 2 authenticators registered to one account, one web app account, if that makes sense.
I'll just jump to the next one. Would you recommend implementing this ourselves or to use a recipe in Node Passport package to handle the flow?
I would always recommend using a proven package to do this for you. To write this, there are three levels of implementation. One is writing your own WebAuthn flow, like the whole thing, getting your server to send the challenges, make sure they're cryptographically randomly generated, and all of those things, and the whole flow. That I would never recommend, because that's almost as bad as writing your own crypto. So we always try and make sure that we're using something, using a library that's proven, that allows you to 2 things. 1, rely on something that's probably been seen by a lot more eyes, and 2, reduce the amount of maintenance you have to do on parts of your application that aren't actually core to your business, if that makes sense. So that's the basic one. The top level is using an identity provider and all of their libraries, so that the whole thing is done end to end. If you wanted to go somewhere in the middle and you wanted to can't actually think of an example in the middle, so I guess my answer is no. Don't write your own. There's always got to be some coding you're doing, though, because you're implementing the SDK and you have to integrate that within your application. Sure. Yeah.
Cool. We've got how would you go about with cross-talk authentication, cross-device authentication? Wouldn't you need a cross-device authentication method, which would become the weakest link?
Cross-device authentication. try and understand the question. Where is that one?
That one's on Slido. That's from Erwin. He's like, how would you go about with cross-device authentication? Wouldn't you need a cross-device authentication method, which would become the weakest link? I guess it would become a weakest link if you had multiple devices. So we've already kind of covered that.
Erwin has voice powers, given that he's one of our other speakers. So maybe he wants to jump on. But does this mean if you want to authenticate, like say, for example, I'm looking at a website on my phone and I want to authenticate to an application by touching the fingerprint on my Mac? Is that the kind of thing you're talking about, Erwin?
He's not on the call anymore.
Well, in which case he doesn't deserve an answer. No, I'm kidding. If you did want to do that kind of thing, that's the link then, and this is probably a bigger question that needs a bigger answer, and I don't know how much time you want me to spend on this, but essentially if you think of, so the OAuth protocol has a number of different auth flows, and one of them is called device flow, which is the one that when you plug in a Google Chrome onto your TV, for example, you don't type a username and password in to the Google Chrome by plugging an external keyboard or using a mouse pointer. It gives you a code and you verify it on your phone. And basically that's using a form of device flow where you're using a device to log another device in. So you could use device flow as the mechanism for logging that third-party application in, or the device on the system on the other, and that's a secure flow. But then when you're using your mobile phone to authenticate your TV, for example, via device flow, your phone is going to require you to authenticate yourself, and for that you can use WebAuthn.
So he's followed up with the situation. So the situation is you need an account that you can use on both devices.
Zoom crashed. You need an account that you can use on both devices. So let's go back to the hardware store again. I'm on my phone, I'm out and about, I create an account, I've got my okay, yeah, I think I see the issue. So I'm out and about, I've created an account on my phone, I then go home and I'm on my laptop and I want to log in there, but I'm using a fingerprint on my phone rather than something that I can unplug from my phone and plug into my laptop. Therefore, I'm going to have to re-authenticate somehow and link those two accounts together. So there's two ways you could do that. The first one is to use that device flow again, which requires the website operator to allow that as to codify that, essentially, to make that a login mechanism. Potentially that could be pushed to the identity provider level as well to allow that, so that you could have an optional login with Facebook, login with WebAuthn, or login via approval from another login, that kind of thing. So you could do it that way. The other way of doing it would be to have an account linking mechanism. So if I've got an account on my phone and I've got an account on my laptop, then the identity provider could then detect that or you can instruct it that they are the same account from both accounts. So I can log in on this one here and say, hey, I'm also account. It'd probably be matched on email address, but you'd find some identifier of the other account if it's not email address, and you'd say that's also my account. And then so from your web browser, you say I want to link with this account on your mobile phone. You then get a message saying this account here has just been requested to be merged. Do you agree? You've then got to accept from that account, and then the merge can happen. So it'd be a double opt-in. So
yeah, if anyone's familiar with some of the different chat clients and such, they employ a lot of those different mechanisms to be able to sign in from computer or sign in from your existing mobile account. So that works. So last one is, what protocols and features does a hardware device need to be supported?
FIDO 2. That's basically it. Yeah. Simple
answer. It's good. Thanks so much. That was wonderful.
Thank you.
That's good. Cool. Virtual many claps. Thank you very much for all of those questions answered as well.
Cheers.
Cool beans.
I shall stop sharing then so you can have the control back.
Okay, thank you. And we'll jump back in and get Christian to jump on and explain to us what their path was to NextJS.
Hello, everyone.
Hello.
See my presentation?
Yes, we got everything on the screen. Thank you.
Great. Cool. So I've been listening to all these BrisJS talks for the last 3 years, and I was a bit shy at the beginning, so excuse me that this is my first my first talk after all this time. I wish I could send you virtual pizzas. I really miss them, and also drinks. So hopefully we can go back, I think in July or something. So yeah, we have Berlin, Sweden, and I guess Australia. Let me know if I'm forgetting anyone else, but thanks everyone for waiting so long. And yeah, I'm gonna speak about this path that we took to get to NextJS, which took us 4 iterations of website, a website for the aimmentoring.com organization. So I started to work at AIM in 2017. AIM believes in a fairer world where kids outside the margins can achieve educational equality. We do this by providing mentoring programs between disadvantaged youth and university students around the world. We're currently in Nigeria, South Africa, US, Australia, and Uganda, 5 countries. So yeah, this sounds pretty stable across almost 3 years, but believe me, like after being in other startups, I never thought nonprofits were some sort of like fast pace like this. So it's been kind of a roller coaster. And what I'm going to do today is like some sort of a history class of how we build this site. So let's get to it. The first version, I'm not going to speak a lot about this because I wasn't present by then. Oh, I went too far. Basically, what I know is that it's been built in using some sort of Flash and a PHP on the back end. It was just a solo designer by then that self-taught PHP, and the site by that time, it fulfilled the purpose. The organization can inform all the things just by having this site, and it wasn't that complex by then. Then in 2017, when we started Strip, we started with this version 2 of the website, which included for the first time a CMS. This CMS was Craft. It was hosted in VPS on Voucher, and primarily it was just server-side code. So you had this traditional server, client-server application. It was the first code base for AIM in Git. We started to use GitHub by then. So it was, yeah, PHP, HTML, CSS, and a little bit of jQuery with a MySQL database. When I entered, I remember looking at that jQuery code and saying, oh my God, it's 2017. But yeah, again, it was the purpose by then. Deploy was taking 10 minutes more or less. We had to restore and back up the database if we needed to do something on that developer environment. Images were all into the CMS, so everything was stored in the same server in Voucher. The cache strategies were all from the CMS. So this team by that time was just one front-end designer, which is who brought me in, Misha. Hopefully he's on this call as well. And yeah, half of a full stack engineer, which was me, that I landed a bit after the site was built. So after that, back then we were asked to start a whole new redesign where we'll hire an external agency. This improved the first code base considerably because we not only implemented the first bit of React, which was more or less 40% of what we already had transferred to React, but also we implemented Heroku as the hosting platform and AWS for the assets. So we got a bucket, we put all the assets there and all the images, and it improved the performance considerably. Deploy was taking pretty much the same because we still needed to replicate the database. The whole code base was in one Git repository as well. And yeah, we started to play with this agency, and they started to have like pull requests and a little bit of a workflow working there. By then, we were just 2 people again to maintain the site once it was built, and it didn't last that long. I think it was even less than August 2018, just a few months. That's when we had this new campaign, which involved another redesign. This new campaign was gonna bring us 1 million visits in about a week. We were featured on BuzzFeed, so yeah, we're expecting a lot of traffic. That's when we decided to build this team, which included 1 UX designer, 2 front-end designers, and 3 full-stack engineers. The approach that we took here is, okay, we already have Craft, which was our CMS. Let's try to do this as a headless CMS, so then we can decouple the structure and go away from this traditional client-server architecture with like all the code in the server side, and then have a client-side application fully on React that the whole team was proficient on mostly, and then on the other side, the PHP backend, which will be completely coupled. So primarily we focus on the client-side code. We had 2 code bases and now 2 environments. So we had production and staging, and we could easily build things between those 2 environments and share code and promote code when was needed. Craft CMS was configured as a headless CMS, which means, yeah, by then it wasn't that easy to create a headless CMS with Craft. It required a lot of PHP code. So every time you changed something on the CMS structure, you also had to create the services in order to serve that to the front end. So yeah, it was kind of a back and forth there. What else? We started with a Create React App boilerplate, which means we got a lot of benefits from having a progressive web app and a lot of enhancements coming from the React team. And the structure was way easier than when we had this client-server traditional architecture. Back then, September, more or less September was when we went to production, but the development started around June, July 2019. And there were some conversations around static websites and the Jamstack. It was already time to change this a little bit. So we tried to do some pre-rendering using a package called React Snap. That brought us a lot of problems back then, because every time they build on React Snap, well, basically what React Snap does is you can pre-build your whole site, and at the end of the day, you have as a result the whole site in HTML files. What happened was that sometimes we had videos and other things that React Snap couldn't render properly. So suddenly the build was breaking and we couldn't go to production just because of React Snap. So it took a little bit of back and forth, and it was taking a lot because we had also dynamic pages. Back then we had a blog itself into the website. So building the whole, all the pages on the blog was taking too long. It was, I think it was around 150 pages in total. So we tried to enhance the deployment a little bit, but yeah, it was taking a lot of time. That was a structure that lasted the longest. It was a lot of sacrifice for the team to get this onto this point. But at the end, we decided to invest in the last architecture that we have right now, which is V5. This is a current version of the website. We decided to shift completely out from Craft as a CMS, and we started to use Contentful, which includes out of the box an API that you can just query and create the content, and you don't have to touch any code in order to get that onto on the front end. So we can say that this is 100% client and serverless code. We shifted out of Heroku for the hosting. This was becoming very expensive in terms of performance, and if we needed a good server that can hold all the visitors that we had, yeah, it was costing a lot of money. So Vercel and now, which is something that Erwin mentioned in the first talk, they have a structure which is a price per month, and you don't have to worry about the architecture underlying it. So this is perfect for static websites. The main thing that we implemented here was NextJS, which is a hybrid between static rendering and a server-side rendering. So basically, you can mix those two strategies in between the same code base and get to a point where we're saying, for example, you have a blog. Okay, so these pages will be rendered on the server side. You have these other pages like the homepage or the CEO page. Okay, these pages we're going to render as a static. And that brought us a lot of benefits in terms of performance. We're almost achieving 100% on all the measurements from this application from Koogh, that I can't remember the name now, Lighthouse. So yeah, in Chrome you can measure performance, and Next.js is actually really good for that. And out of the box, you have a lot of benefits from it. Passing to Vercel, we also achieved HTTP2, which is something that Heroku still didn't implement. And it's easier to route, to create the routes. You don't have like a router in the same way that we had that in Create React App. With Next.js, you're just creating folders, and those are your routes. So you can ignore there are some techniques to ignore folders, but basically it helps you to like create pages easily. It's just creating a new folder and the page is there. And they also have a number of examples that are really, really useful for different approaches that you can take. And in this way, we also implemented some GitHub actions to check the lint structure of the project and also measure performance. So if you see any pull request, you can have like a list of the lint errors that you might have, also the values of the performance and how much that changed from one side to the other. Deploys now are taking 1 minute, and we started to implement our blueprint library, which is basically a components library. This involved the same team, so this will be the second iteration of this website for the whole team. And yeah, that's what we got right now. We're really happy with it, and these are some of the learnings on that whole path. So basically, the first one, avoid jumping to the trendy stage right away, is that, for example, when we built the first version on React Snap, the ecosystem was just simply not ready to go on a static pre-rendered site on the size of our website. We tried with Gatsby.js some examples, and I remember back then they were just going out of a beta 2. The whole project wasn't even compiling back then, the current project of them. So it took a little bit of time to also get Next.js to work. I think the previous versions that we tested were just not that mature as this. I think they are in the version 9.3. And you can see in the whole ecosystem and the tech community how Jamstack architectures are actually finally getting on a place that are stable and easy to implement in a different ramification of projects. Building an engineering team inside a nonprofit took a lot of energy, but looking at the investments over time, you can see the progress on what we achieved. And this is really refreshing. I actually love to work in this configuration, and I would love to keep working on that. Extracting complexity as soon as possible. The version 3 and 4, we included some sort of volunteer applications right away on the side. And when we created the team, one of the things that jumped right away was, hey, so if we have applications to be volunteers and the volunteers are coming recurrently year after year, why don't we build a whole account system that they can just create an account and have the application there, and it will be easier to apply year by year. So at some point we decided not to implement this on the website, and this made things so much easier. We extracted all that logic into another project that was basically fully client-side, and it didn't require a lot of traffic like the institutional website, right? So that helped a lot in order to advance and move faster. And the last one, the maintenance costs change and it gets cheaper over time. So Erwin also touched on that on the first talk, which is a structure, the same architecture in Heroku, which is a server-side architecture, can cost you a lot of money, which for a nonprofit will be a bit expensive. If you compare that to a static website where you're just hosting HTML, there's so many different options right now, and it's so easy to get to that point. So I would recommend right away to look into those costs. These are the next steps in terms of what we can do with what we have. So NextJS have a new feature, which is a preview version, so you can edit on like in the same browser, let's say. And this can be implemented with the headless CMSs. So this is something that will help not only the dev team on one side, but also the communication side of AIM to get to features or to anything faster. We're also planning to go open source with the hope of getting some help from different volunteers on the AIM side. We have around 2,000 volunteers per year, so we could start to build a community around the code that we're creating. By promoting our components library, we can get the chance to build other micro websites. So we have a lot of inside our programs, a lot of internal projects that will get more visibility with a small website. So we're trying to achieve that as well. And another option is also to start from zero and use something like Webflow, which is a codeless environment. But yeah, that's just on the discussions. And that's,
Fantastic. Thanks very much. That's a great journey. We got a bunch of questions there as well. That's cool. So it may have been answered as we went through, but so I'll read out the first one. So Craft was like an API. What was it serving while acting as headless?
So Craft, basically at the beginning, we use it in the client-server traditional CMS architecture, and then we were able to create, there's like a plugin called Element API that will give you an API. Basically, what Craft was giving us is the structure of our whole blog posts, or for example, information around the homepage and how we can structure that, just organizing the content of the website rather than just the images or let's say the whole basic shell of the website, right? Like the content side of things.
Yeah, cool. Knowing what you know now, what would you have done differently?
That's a good question. I think there were some iterations that we could have merged into one. For example, between the third and the fourth, we could have go right away with the fourth iteration and save a lot of time in terms of deployment and things and reworking, right? That would be my main thing. Yeah, maybe that, and we'll get back to it.
Why was Contentful a better fit for the problem?
So basically, with Craft, we had to go again to the code base every time we need a new structure in the CMS. Craft didn't get the Element API right away, and that produced, like, let's say, double handling in terms of the work. But then we also needed to host Craft into a particular server, let's say, with Heroku, and that's involving PHP plus maintaining the database plus the cost of having a database and all of that work. Basically, in Contentful, you just spin up a new environment, you create your content, and you get an API with all that content. It's way easier if you're thinking as a front-end developer to go in that workflow.
You've doubled the team for V5. Was that because it's more to maintain, or more is being done in-house instead?
Yes, so for B5 and B4, actually when we created B4 was the moment that we doubled the team, and that was to tackle a new architecture in a short amount of time. Then for B5, we had the same team involved in other projects, but with the learnings of before, we could get to a better place.
Awesome. How did you think about effectively scaling your solution to meet the needs of growing users by migrating the Craft CMS into Contentful plus NextJS? So I guess focus on scale. How did you go about thinking through that?
Cool. So having on before a server-side architecture took us a little bit of time in terms of managing the resources in Heroku and having like an auto-scale processor with Vercel, which is a new hosting environment. You have that out of the box. So they have automated ways of scaling depending on your traffic. So at the end of the day, you don't have to worry about it in terms of the front end side. For the backend side, I'm not sure about Contentful and how the performance of the API is working right now, but I guess it's something similar to what you have right now in Vercel, and it's auto-scalable. In Heroku, you're having to manage resources, like hardware resources, and say, okay, I know that I'm gonna have more traffic. I have to upscale this particular server because I'm gonna receive more traffic, and you can pretty much touch the hardware there. And yeah, like for a nonprofit, that's a lot of work that maybe you don't need.
Yep, absolutely. Sounds great. And that brings us to the end of the questions. Any closing remarks or anything you want to add?
That's all. We're now launching a TV show, which is live every weekday at 12 p.m. AST on YouTube. So you can go to mentoring.com and jump to it. This is a way of transitioning our in-person program to a TV show. And we're also having these amazing hoodies, which you can buy in going again to mentoring.com.
That's awesome. Cool. Well, thanks very much for contributing your journey there and talking us through that. That's awesome. Again, virtual claps from everyone on involved and on the channel. Thank you again. I'll just get you to stop sharing, and I'll just throw up the last slide and leave people with some contact details. Awesome. I will throw that up there. Don't need to hit the share button. All good. Cool. So yeah, thank you very much to everyone at home for joining us. It's been a jam-packed night. Huge talks. Over 25 minutes from everyone, which is fantastic. Thank you so much for contributing all this time, going through and volunteering when we were in need. Really appreciate that. If everyone else can do the same, and we can have a lovely July full of talks, I'd be most appreciative. I will badger everyone on the socials again and remind everyone. So this talk should be processed and up again for rewatching very soon. Feel free to share it with friends and let them know that BrisJS is still around during this time of sheltering in place and staying at home. Yeah. Let us know your feedback. Let me know how I can improve. I'm open to every suggestion. So I'm going to throw up the feedback poll. We've had the the giveaway question. By the way, somebody jumped on there with an answer, the correct answer, and didn't leave their name and email address, so I can't send them anything. They're the only ones that managed to answer correctly. Yeah, if you've done it, I'll bring it back up. I'll give everyone a good 5-10 minutes just to be able to do the ratings and open poll. I'll just do that now. Okay, so open text poll. So if you've got any suggestions or feedback, feel free to do that. And after the stream ends, I'll flick it back to pretty much leave it overnight to have the open giveaway question answers. So if we have multiple correct answers, we'll pick at random thanks to the random generators online. But thanks very much, everyone. I really hope you've been enjoying tonight, and yeah, we'll be in touch with more events coming up soon. And I'll sign off now. Thanks again, everyone.
Thanks, Kevin.